And welcome back. I'm on to the final day of the month. So it's the 31st of Jan, higher plus 5 a day. And let's go with the first question. Okay, actually, nice bit of algebra today. I quite like these questions. So this really is just a case of being very careful and not messing it up, which I know sounds obvious, but lots of silly mistakes come in. So write it out. Don't try and do it in your head or try and be clever, because frankly, there's no upside. And if you know what you're doing with the exams, time is not an issue in the exams, as long as you're sort of aware of all the topics. Anyway, let's get going with this one. So I'm going to expand the first two brackets, which is going to give me 4x squared plus 3 times 2 is 6, and double it is 12x, and 3 times 3 is 9, and we multiply all that by 2x plus 3. Now, for space reasons, I'm going to continue up here. So I'm going to multiply everything by 2x, so that's going to give me 8x cubed plus 24x squared plus 18x. Then multiply everything by 3, so that's going to give me 12x squared plus, where my 3 times 12 is 36x, and 3 times 9 is 27. Now, because I've written things in nice little columns, that makes it very easy to add up. So that's going to give me 8x cubed plus 36x squared plus 18 and 36 is 56, 54, so 54x, and then add, let's just make that x slightly neater, x, and then add 27. And that's the first question done. Next question. Okay, so we have a make m the subject of the formula. Now, notably, we have two m's, one m here and one m here. However, we start with them both being on the same side. I was going to say correct side, but the same side of the formula. So this does make it slightly easier. So therefore, I'm just going to say that E equals, and if I factorise the m out, that's going to give me GH plus a quarter V squared. And then if I divide by that thing in the brackets, that's going to tell me that m is equal to E divided by GH plus a quarter V squared. Now, that quarter, I don't really like that quarter. There's nothing wrong with that quarter. Perfectly acceptable. This is probably okay in the exam unless it tells you otherwise. But I'm going to multiply everything top and bottom by 4. And so that's going to tell me that m is equal to 4e divided by 4 lots of GH plus a quarter of 4 is 1, so plus V squared. Just looks a little bit neater, doesn't it? Next question. Okay, very similar to the question we had yesterday, actually, isn't it? So calculate the sum of the first 50 odd integers. So the first question is, what is the 50th odd integer? And you may just know this, but again, silly marks if you get the wrong one. So let's just work it out quickly. So if you think about my integers, they go 1, 3, 5, 7. So in other words, the nth term is going to be, they go up by 2, and they take away 1 to stop with the first one. So therefore, U50 is going to be 100 minus 1, which is 99. So the question is effectively, can you add up the numbers 1 plus 3 plus 5 plus 7 plus 99? And I'm going to write it out underneath. Now, if you do International GCSE, you will know about the SN method. You can use that, that's fine. But I'm going to do the slightly longer method. And then if I add all these numbers up, they all add up to 100. And I have 50 lots of 100. But I'm doubling my sequence, so I need to divide that by 2. So in other words, I've got 25 times 100, which is going to be 2,500. Not as bad as it looks, is it? Okay question. Next one. Solve the inequality. And of course, this is a quadratic inequality. So there's very definitely a technique here. And the first question is, can I factorise it? Now, I think I can. I'm going to have a guess, and then I'm going to see whether that works. It would be unusual not to be able to factorise one of these questions, but doesn't mean you can't. 1 and 1 means these must be 1. And 12 is either 6 and 2, 12 and 1, or 3 and 4. But because 3 and 4 add up to 7, I'm going to guess at 3x and 4x plus 1. And if I expand it quickly in my head, so 3x times 4x is 12x squared, good. 3x plus 4x is 7x, which is what we discussed before, and 1 times 1 is 1. So that's worked. So that tells my critical values are going to be minus a third and minus a quarter. So not nice numbers to end the month with. So a quick graph looks like this. And there's my, let's draw it here for the sake of argument, and there's my y-axis. So minus a quarter comes first, which is here. Minus a third is here. I want all the values that are below. So therefore, I want all the values that are between minus a third and 1 quarter, inclusive, because that has an equal sign as well. Next and final question. How many interior polygons have integer angles? I'm thinking quite a lot. Let's do it a slightly different way. So the exterior angle is 180 minus the interior. So if the interior is an integer, that means the exterior will be an integer as well. And for a regular polygon, the exterior angles is 360 divided by the number of sides. So it's basically saying how many factors of 360 are there. Oh, this could be a bit messy, isn't it? Okay. Right, I'm going to write these down. This might be my first ever attempt at speeding up a video because you really don't want to watch me do this. So I've got 1 and 360. Let's write it here. I've got 2 and 180. 3, 24. That's right. 20. It doesn't actually matter if I get the numbers exactly right. It matters the count is correct. And 20 goes to, well, 20 is 180. Divided by 2 is 18, so that's going to be 18. And I think there's one more, isn't there? So 20, oh no, don't it? 20 and 18 match up. That's it. God, that was strenuous, wasn't it? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. But there's not though, is there? I've just realised. Because you don't include one side and two sides, because they don't make a polygon. They're a straight line and a straight line. So therefore it's 24 minus 2, which means my answer is 22. Wow, if you get a quick way of doing that, please let me know, because I can't think of a quick way without just writing them all down. Nevertheless, nice little mix of questions again. So if you got all those, well done. As ever, do like, subscribe, and I'll see you next month for February's question. Thanks all.